This is LGT8F328 microcontroller board, similar to the popular Arduino Nano. We're going to be programming this microcontroller board using the Arduino IDE.
So we're gonna start our Arduino IDE. Now we need to install our LGT board. So there are some links here. See these three links. We're gonna copy them. Copy this link. Go to our Arduino IDE, File, Preferences. Then additional boards manager URL. Click on this, enlarge it. The links that we have copied already. So you see, we paste them here. Look at them, paste the links here. Then you close the window. Go to Tools. You see Board Manager. Click on Board Manager now. After the Board Manager opens, while you are on your online, you will install the LGT8F by Logic Green and then the LGT. So LGT installed. Then after installing, then come back to your tools. Then we go to boards, down. You see board, go down, you see Logic Green. That's after you have installed, then you see this. And then the other one will show you AVR. You can see them. So this is one that we are going to use. Now you select this LGT8F328. After that, you need to go back to tools, come down to clock, make sure you select 8 MHz. After that, come down to variant, make sure you select this. We are going to click on this. Now go back to tools, so you can see, make sure this is a nano style selected. Now, our board, we're going to install the drivers for the board, our serial drivers. So make sure you go to Google and you download these drivers. You see these two drivers. Just type this on Google, CH341SCR. You download this file, and then the other one CH9340SCR.exe. So these two files, just you download them and install it. So you can see this, you click on this to install. I have installed this, so you click on this to install, and there will be a confirmation of the installation. So you do the same thing on this. After installing this thing, go to your manager, right click on this PC and then go to manager. Now what you do, you plug in your board, the LGT board, you connect it, you plug it to the LED port on your computer. So while this, now click on this device manager. Then see COM and LGT, the ports. You can see this COM4, so our board is being installed. Now we to back to our Arduino IDE. Now go to tools and you can see, make sure the board is open so you can see. So that's how you set up the LGT board. So now we're going to write first program. Make sure you save the file. Make sure you save the file name. So that's the file name. So that's the file name. So our program header. So this was the new information. So we're going to start with digital input, digital output, analog input, analog output. So following our circuit diagram, we have two LEDs, LED 1 on pin 13, LED 2 on pin 10, push button on pin 12, potentiometer on A0. So now you start by typing this. We're going to start with the LED on pin 13. We're going to rename the LED. Let's call it LED 1. Use on pin 13. Then the second LED. Now the second LED, we're going to use it for, the first LED on pin 13 level, I'm going to use it for digital output. Then the second LED on pin 10, we're going to use for analog output, which is PWM. So we're going to call down PWM pin. That's on pin 10. And we have a potentiometer. Let's call it port 1 on the pin A0. Then we have push button. Let's call it button 1 on pin 12. So that's what we going to do. So now we're going to write in some declare some variables. So we're going to declare a Boolean variable, true or false, 0 or 1, high or low, which is going to store the state of the push button. So let's call it button 1 state. So call down button 1 state, and then let's declare an integer variable. Let's say analog value. So analog value, that's we're going to store the value of the analog inputs. We're going to use analog. This one we're going to use for digital inputs. We're able to store the value of the digital inputs. So that's what this is going to do. So you can see. So here we say we rename pin 13 as LED 1. So the same thing. So this is going to store the analog value. So this variable is a variable to store analog inputs. So yeah, we're going to have another variable again to store the PWM value. To store the PWM value. And then let's see what value there. Okay. So we're going to use this. We'll read our push button inputs, either 0 or 1. It's going to hold 0 or 1. 0 means the button is pressed, 1 means the button is not pressed. Then this one is analog value, going from 0 to 1 or to 3. Then this one is going to be PWM value. We're going to read the value of the PWM. So let's start. Now, what to do to set up our pin. We need to set up our pin mode and leg 1. So means we are configuring the pin as output. We have a PWM pin outputs. Now you can write this way, it will all work. But make sure you leave a character space. Don't join it so you can see. So what this interprets is that we are set pin to output mode. What this interprets, what the statement says. So now we have 2 pins that we have set to. Now we have our push button. Our push button 1. Now the way we're going to do this, it is an input pull up. So this is means set pin to input mode and activate pull up resistor. So the pull up resistor is a resistor you connect it to an IO pin. So the 5 volts. For a 5 volt board, that's what the pull up means. So because we are using for push button, so we don't need to connect extra push button again. So we need to do something else again here. This LGT8 board, the analog input mode, we need to set it to, because the analog inputs works on the 12 bits, so we need to set it to 10-bit mode by issuing this statement: analog read resolution. So that's 10. So that is 10 bits ADC for LGT8F328. So you can see, so the 10 bits 10-bit mode and the ADC. So that's what it means. And then we need going to be using our serial monitor. So we need to activate the serial monitor by issuing this. So it means activate serial communication at 9600 bits per second. So that's what it means. So now we need to bring something serial dot. We need to do this to print empty the scene, wait for like 100 milliseconds. This means wait for 100 milliseconds. So we're going to print a welcome message, just print line. We say welcome to LGT8F328 programming with Arduino C. So that's how we want this to print a welcome message on the screen. So now we're going to start right with our digital input. So we're going to do digital input and the digital output. So we have declared this already, this button state, button 1 state. So we are going to say button 1 state is equals to digital read button 1. So you see this. So this is so now let's we're going to give a little delay of 200 milliseconds. So now we're going to display message on the serial monitor the state of the push button. So let's say serial dot print line digital input. So the value of the digital input, we're going to do something like this. So serial prints. So give a character space. Here now we're going to put line. So that it will be printing line by line without printing the button state. So you can see. So when we press this push button and hold it, you want to see it 110. So let's upload, click upload and there. Wait for program to upload. Uploading. That's uploaded, so let's open the serial monitor. So you can see now the button, let me press the button, so you can see I'll press the button, let me release the button, so you can see digital input, so you can see. So that's how you do digital input. Now, we want to do digital output now we want to use the digital input to control digital output. So this is what we're going to do. Come here, we'll say if button 1 state is low, that's if it is 0. So if it is 0, so what do we do? Give a little delay for like let's say 350 milliseconds. So after that we should do what? We want to turn on the LED digital right LED 1 high. So you can see. So this means turn on the pin. So that's what it means, making the pin go high. If you write low here, high to turn on the pin, low to turn on the pin. You understand? Now, when we press the push button and release it, the LED will just stay on. What if we want it to go off if you press the button again? So now this action means I have disabled this line of command. This command now I've disabled it. So this is what we're going to want. We want the button to be controlling the output. We press it, it comes on, we press it again, it goes. So that's what we want to do. So This is what we're going to do. We'll write it this way. We'll do this digital read LED1. So this is what we're going to do. So this one means that we're going to toggle the pin. That's the LED. Toggle means you change the state. If it was 0 before, you make it 1 like that. So that what it's going to be flipping the pin. Now we're going to be adding the information here now. Again, we're going to add. Want to print again on one line. Make sure you're going to remove this. So we're going to do serial dot print. We give a comma serial dot print. That's digital output. So you see, and then give the character space. Then we're going to put serial print online. So what are we printing? The digital output. Now this is what we're going to do. We're going to do something like this. Digital read LED1. This means that if the LED1, if the LED is on, we should show a message string as text that LED1 is on. Else, show the message LED1 is off. So you see. So this is what we need. Let me shift this to down line there so I can see everything clearly. So you see, the whole of this is going to print on one line. This we can see LM here. The end of the line. So digital input to show the digital input, the digital output is going to show it. So let's upload this. So it has uploaded. So let's open the serial monitor, then check. So you can see, press and release, press and release, press and release. So you can see digital input, digital output, digital input, digital output. So you can see, so we have successfully done digital inputs. So we're going to continue. We're going to do analog inputs. Analog inputs. And an analog output. That's a PWM. We have a variable here, an analog value. Analog value. We see our analog value equals to analog read without reading ports 1. So our potentiometer is connected to A0, we should rename it port 1. So we are reading port 1. Now we are going to add this to the display. We're going to add this to the display. That's the serial.print. 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 So serial.print, you put comma. Make sure we take this because we are adding number. So we're going to say analog inputs. Analog inputs. Analog inputs. Then we print serial print line, serial print line. What are we printing here? Analog value. Analog value. Let's upload this to our board. So I'm going to take my screwdriver and adjust the potentiometer while we look at the analog inputs. You can see I've turned it down to 0, turning it towards 5 volts. You can see I'm at the far end of the 5 volt side. You know, the voltage is below 5 volts from the USB port. So you can see our analog inputs. So you can see. Then press the push button. You can see I've turned on the LED. The LED one is on. Turn the LED off. The LED one is off. So you can see digital input, digital output, analog inputs. So you can see all showing on one line. You can see. So we are going to do analog outputs that's called PWM, pulse width modulation. We have declared a PWM value. Now we're going to make use of it. We should take notes. This is 10 DC, which reads from 0 to 1023. That is 0 to 5 volts. So these are digital steps. So that's how the ADC works, the analog to digital converter. It's analog to digital. They are in steps, 0 to 1, 2, 3 steps, which is in 10 bits. We're going to do something here, our PWM value, which we know it reads from 0 to 255. Our PWM value that we have here, we have declared here. Now what we're going to do, we're going to convert this range 0 to 1 to 3 to 0 to 25, and the other we're going to use map function. Map. What are we mapping? This analog value, which is notarized from 0 to 1023. Now the new range now we are mapping into 0 to 255. So that's how we convert this into this range. So we are mapping 0 to 1023 to 0 to 255. PWM value. Now we can apply the PWM value. Now that we have converted it, so this is how we do it. Analog write. Analog write. Which pin are we writing to? Our PWM pin. And what is the value we are writing to? Our PWM value. You can see. So this is where we have analog output that is done digitally. I call the pulse width modulation. Analog output PWM that's using digital signals to control analog voltage. So we're going to add our display output on the serial on another line. We're going to add the PWM value. We'll add PWM value there. Let's copy this. Take away this line. We say our PWM value. So we add this line. We then let's give it space. We then print our pulse PWM value. Make sure to put LN here, line. Or I can move this down. Good. So all will print on one line. Let's upload this to the board. So let's open our serial monitor. So you can see our PWM, and I'm going to adjust the potentiometer. You can see PWM, you can see we are mapped it to. Now this is so you can see it. So we are doing 4 things there. Digital inputs. Press the push button and release. You can see LED is on. Digital inputs, digital outputs. Press the push button again and release. The LED is off. You can see. I adjust the potentiometer. That's an analog input. You can see. I'm adjusting the potentiometer, analog input, and then analog outputs. So you can see. I'm going to put the video of the board because it's recorded separately. I'm going to put the video of the board so you can see. So you can see. So we have covered 4 practicals here. Digital input, how can we do digital input, how can we do digital output, how can we do analog input, how can we do analog output. Now, a lot of things that we are going to be designing. We're going to make use of this. Very important things that
So this is our circuit diagram. You can see the circuit diagram. We have our 10K potentiometer connected to A0, and then we have our push button connected to pin 12. We have an LED one connected to pin 13, and then we have the LED 2 second LED connected to pin 10. Now the push button will demonstrate digital input with it. Then the LED one on pin 13 demonstrate digital output with it. Then the potentiometer connected to A0 demonstrate analog input. Then the LED on pin 10, LED 2 demonstrate analog output. So this board, as you can see, is powered from 5 volts. So you can see we have the board here. You can see the wiring on the board. You can see it right here. This is LED 2 connected to pin 10. LED 2 connected to pin 10. This is LED 1 on pin 13. We have pin 13 here. This is LED 1. You can see it, the LED. Then we have our push button, which is connected to pin 12. Push button on pin 12. Then we have our potentiometer, which is connected to A0. You see, make sure you connect your potentiometer correctly. The two outer pins are on 5 volt and ground. You can see. Then the middle pin goes to A0. This capacitor here is for noise, to reduce noise on the analog output, just as we have it in our diagram. Here. The two outer ends of the potentiometer is between 5 volt and ground. Then the middle one, that's the white part, goes to A0. You can see there. This is 100 nanofarad. You can see coded 104, 0.1 microfarad. The push button, one terminal to pin 12, the other terminal to ground. Then the LED and the resistor is connected in series. You can see. So the anode of the LED is the positive side, while the cathode of the LED is the negative side. The negative side is not going to ground. So these are the coupling capacitors we have here. Just as you can see on the board here, the polarized and the non-polarized capacitor. Now here, if you are going to power our board from external source, so here we have our 5 volt regulator. And we have the diode. Then we also have a buzzer. We will be using it on our next video. We're going to be using this buzzer, and how we can power this from 5 volt. But for now, our board is from the 5 volts of our computer. So now I'm going to connect the USB. Then I'm going to connect this to the computer. So we have our board here connected to our computer. We have uploaded the programs. I'm going to press this. You can see this for the digital input and digital output. Digital input, digital output. Press. So here I'm toggling the output pin, pressing the push button. Digital input, digital output, digital input, digital output, digital input, digital output. So you see here, analog input. So I'm turning this analog input, analog output. So you can see it, analog input, so you can see the LED. Observe the LED. You can see it getting brighter. So I'm reducing that. So you can see analog input, analog output. So PWM on the LED. So you see PWM on the LED. So make sure you can practice this. With the LGT. So you can see our microcontroller LGT. We have successfully programmed it from the Arduino IDE. What Arduino you can do with our Arduino board, this board is doing it. So